Okay, so two things you need to know before I start. First, I'm not very good at speaking without a microphone, so if you cannot hear me in the back, just wave or something and I try to shout. It's also late, so I try to speak slow so you can fall asleep. And initially when Lee asked me to prepare the talk and send her the draft, I was like, this was my top creativity. But then when I started to prepare the slides, I came up with this one. And I also came branded, so I'm committed. And we are going to talk about the dark side of EDA. It's not going to be too technical. We're really going to be talk about the problems that EDA introduces us and obviously how to solve them or to avoid them. So I will start with a story. 6-7 years ago, I was just kidding. I had to catch their faces when my mother said 6-7 on stage. It's like a experiment in human, also called parenting. But a couple of years ago, when I had a conference talk, I spoke about microservices versus monolith. And who here is old enough, or maybe I wouldn't say old, experienced enough to remember that it was actually the architectural debate back then? Yes, I'm not alone. So we actually spent countless of hours debating whether we should go to microservices, keep the monolith, where should we keep the database, and do microservices actually help deployments, or it just make everything harder. But fast forward for today, the world has changed. We don't really, it's not an issue anymore. And if I'm putting aside the really enormous but impressive monolith that Meta is still maintaining, most of the company are either moved to microservices or in the way of, sorry, try to speak fast, or in the way of moving as we speak. Because if I go more extreme, if you're not a small startup looking for the product market fit, you're probably using EDA and in microservices in your day-to-day. So we build microservices, we build a lot of them, we build one for domain, we build around features, and we form teams around that. And how they communicate with each other, how they interact with each other? No one?
Of course.
Before Kafka.
Events.
Before, guys, we are in history here with APIs, of course. So we create APIs and it feels really, really great. But then this picture to this one, because what really happens is every service actually depends on each other, and every team needs some data from another team to actually operate. And every API call trigger a chain of API calls in different services. So we really didn't break the monolith, we just distributed. And we look at this amazing AI-generated photo and thought to ourselves, it must be really another way, because microservices promise us autonomy, promise us fast delivery, and this is where the promise of EDA felt so real, and so this is where Kafka came in. And this wasn't another architectural pattern. This is actually something that changed things, how we operate. And it promised us a lot. It promised us loose coupling. It promised teams that actually have autonomy. It promised us systems that not just break, but actually evolve and scale. And all of a sudden, all the diagrams, architectural diagrams that you have in the company probably includes Kafka in it. If you speak with juniors, they're all a repeating publisher, subscriber, like a mantra. And if you've done architect or system design interview, you probably use some kind of event pass. It's everywhere. And I'm here to ask you, did EDA really solve all of our problems, or we just introduce a lot of new ones that no one warns us about, except Anatoly in the previous talk. But yeah. So this is a nice way to stop and introduce myself. I'm Eti Noked in LinkedIn, or Eti Noked in Twitter. Mother of 3 girls. 2 of them are sitting here, really late to bed. Moved to the Netherlands bit more than 2 years ago. I'm a software developer at heart. but in the last decade or so, I'm managing and building engineering team. These days, I'm head of engineering at px.com, and in px.com, we are building like the next evolution of customer acquisition platform. And of course, I'm hiring, so if you're searching, come catch me after that. Besides that, I'm also really a fan of Lego, love Marvel, and I'm a diver, not very much in the Netherlands because it's really, really cold. And I want to a bit get to know you. So by raising your hands, who here are software engineers? Amazing, most of you. Developers, the DevOps. Okay. I know that there are data engineers in the room.
Managers.
Just before managers. Managers? Only one. Okay. Who use EDA currently? Doesn't matter if it's Kafka or something else. Okay. Who already experienced like the pain? Yes. Only one. Amazing. You're doing an amazing job, or wait for it. I don't know. Okay. So back to our story. Up until now, I didn't share anything. Like besides the questions that I raised, I didn't share any problems. And we go from a monolith to microservices and then to event-driven architecture. And everything seems very, very great. And don't get me wrong, I'm not here to say that EDA is wrong or it's not really solve a real problem, because it does. I'm just here to share that essentially EDA is not perfect. Because some point in time, your system works, like the events are flowing, teams are delivered, shipping, everything is good, but all of a sudden it's very hard to answer like simple questions like, why did this thing happen, or who's consumed this event, or can I change this stuff, or why is production broken again? And this is the moment no one speaks on it, like the fancy diagram, architecture diagram, or the architecture blog. This time that everything just got broken. Because EDA doesn't fail us. In reality, it just introduced a new set of problems, which are in its essence not architectural, but mostly operational or organizational. And I'm here to show you some like common challenges that I've encountered, I collect from my Twitter friends, so in the startup that I've consulted to. It's actually like not theoretical one, real problem that I guess maybe just one of you saw before. So the first one is the first thing that happens, like the first trap that we see, ignore the text, it's really all generated by AI, so I didn't even check if it means something. The first thing that happens is that when someone asks, like, can I change this event? And then, like, we have a teammate said, I think so. Because events actually feel like isolated. They feel like decoupled. Like we fire and forget, right? But in reality, it's like undocumented API, and it's really, really important to understand it. So let's dive for a second. Because if you think about it, when you fire an event, you actually deliver a contract. Even if you're not meant to, even if you didn't document it, and even if you don't know who's going to consume it, you're still defining a contract. And such is, it needs to be maintained. Because what really happens is that consumers start to rely on the structure, on the schema, and the schema starts to evolve without an owner, and productions start to break like with non-obvious ways, and this is not something that we want to know. And the funniest or the scariest thing is that teams started to like be afraid of changing or modifying events even more than you used to do with APIs. So the good news is that it's really, really solvable. We just need to treat our events as a first-class citizens. Oh God, I'm going to stack with words today. So the first tip is really have the contract-first event design. So make sure that you've defined the schema explicitly. And I don't care if you use like JSON or protobuf, just make sure this is close to the code, because we all know what happens with the pages that we store in Confluence. So all the documentation that you have in the contracts should be stored as close as possible to the code. The second one is to define an owner, and this is something that I'm going to repeat so remember that. Producer should own the schema. So consumers asking for changes, producers are the owners of the schema. And essentially, if ownership in general is not something that is optional in EDA. Okay, it's a must here. And of course, document, I enter into that document event like it's an API. Yes.
Can I ask something?
Yes.
So this statement, producer owns the schema.
Yeah.
Is this maybe true with events, but you can also send messages that are commands. So in this case, maybe the consumer should be in charge.
Yeah, I'm talking about events, not yeah. Nice one, nice catch. Yeah, sorry. So document event like it's an API, and when I say it's API, you need to like really define what an event means, not just like the schema, when it's going to be emitted, and hopefully also who are the consumers, and we'll get to that a bit later. And important thing is the versions. Don't make like changes to be silently committed, and try to avoid like breaking changes. If you cannot, 100% cannot do backward compatible change, make sure you version it right, and also document and make it visible. So consumers will know version will change and you don't break production by mistake. And this is something that Anatolio mentioned, like use a schema registry. You can also check backward compatible with that, and also make sure that you have your customer impact awareness while you're doing changes. So this is the first set. And when you start like taking events seriously, this is where the next challenges immediately appear, because now you have a lot of them. And EDA makes it so easy to create events, and all of a sudden you have like order created V1, V2, order created new, very new, and no one really knows who's using what and what is the updated one. And all of a sudden you have a lot of them, and it's not, I mean, the system still works, right? It's not that you broke the system. It's just very hard to track business logic because everything is spread around. So what you really missed is the clarity of the system and understanding what the system is doing. Event explosion doesn't mean you shouldn't, doesn't mean you shouldn't create events. It just mean you need some structure around creating them. And the structure starts with, why did I miss that? Start with event taxonomy. So like to have a naming convention that is very, very clear how to create an event. Don't be creative here, like the boring it gets, like this means that you're doing a great job. So use like order that place, order that paid, shipment created, something like that, to include your domain-based prefix, but also the action. We talked about schema ownership. Here is about event ownership. So the ownership should be visible. So consumers will know who should they come for to ask question. As a rule, like if nobody owns the event, it probably shouldn't exist. And they maintain event catalog, which is really amazing. There is one organization that I've seen done it right. Like one place you can look for an order and see all the events that you can consume and what is the latest version, and when your version is going to be deprecated, all can be in one centralized place, which is really helpful to maintain and understand the events in the system. This is not trivial. That treat event as products. If you think about a product, we build a product with intent, and we know who's going to consume it. I'm not going to release a product to production and guess. But I also have a deprecation period for this product. Maybe it doesn't work anymore and I will kill it. I won't pay for the cloud for no good reason. So treat the same for events. Create it with intent. Make sure that you update and document all the life cycle, and also kill events on purpose. Okay, this is my favorite part of cleaning. I really like to delete code, But make sure that if event doesn't need it anymore, you are sending messages to the consumer, it's going to be deprecated at X, and then you're going to clean it up, and so you don't leave like phantom event in your system. Oh, yeah. I forgot the line before. So when everything really works as expected, we get to the most important part from my view, because when the system actually working, something will break at the end of someday. Okay, we'll have bug and something will break, and you don't want to get to the point that something is break and you ask yourself like, what the heck has just happened? And I mean, if we think about a scenario where we place an order, payment get delayed, and then shipment doesn't send, we don't really know, like, without investigating which part of the system was broken. And this hurts where it matters the most, like in production. Essentially, every investigation become like, every debugging become like an investigation, and like you jump between dashboard, you jump between teams, and it's very hard to get answers to like what really happens in the system, because everything now is distributed. Distributed. And what happens is time to recover just increases, and we don't want that to happen. And most of the time, and this is the ugly truth, most of the time the system doesn't crash. It still works, but something is broken in the flow, and we don't know how to get it because we are blind. Observability in EDA is not trivial, and it's something that you really need to think about it in advance, because now, like looking at the system when it's distributed, and we have several services, and everybody consumes stuff from a Kafka queue without a specific order, it's very hard to predict what will happen. So keep that in mind when you build the first one, and a couple of tips that I shared. First one is enforce correlation IDs everywhere. We did it in booking.com. It was really helpful to get insight on the system. Essentially, you have a primary ID where the publisher send with the event itself, and then every consumer that consumed this event put this ID in every trace, metric, log that that they are being produced, and that way you can actually track the flow from the beginning until the end or the consumption. The second,
is that different from the parent, the trace ID, the parent trace ID?
Yeah, because it's unique for the event. So essentially, the publisher define it, whatever it is, and then it's unique in the system, and you can search for it in your logs, in your metrics, or whatever you want to see what happens to the event. The second is to think in business flows, and not just services. Back then, we used to monitor like CPU, RAM, memory consumption, stuff like that. But in EDU, it makes more like the need more critical to actually monitor and alert on business flows. So imagine like to track a number of order paid versus number of shipments created. So like this number should be the same, and if it's not, we have a problem, and we can check before support cases start to raise. And this is kind of trivial, and there are a lot of tools out there to give you that, but build event logs that are shared. So all the services put in the same stuff, so you can actually see the track. But the important part is make it queryable. So you don't need to scroll when you want to check what happened yesterday, but you actually can query the data and see what happens. First one, which also not that trivial, but important in EDA in general, you need to make sure that you can replay event. It doesn't matter if like it once, twice, or 10 times. The end result will be the same, because the reality said that the bug happened after the event was fired. So if I fix this bug, I need to be able to fire the event again and make sure that I'm not creating like another woes in the database, or charge the customer twice or something like that. So make sure that you feel safe to replay events, so you can actually solve the problem. And the last tip in that section is to visual event flow. The rule of thumb said that if you can visual the flow, you cannot operate it. Like you don't really understand what happens, and when like shit got the fan, you won't know what to do. So make sure you have a visualization of the event flow, who consume it, and how it operates. Yes.
Question about the make replay safe and boring.
Yeah.
If I replay an event of mine, I have, of course, because of the EDA, an entire chain of events behind it. What would be your suggestion for, if it's not just my producer or one consumer, there will be possibly multiples or a chain?
Yeah, so it's like this rule of thumb is for everything. You need to make sure that the operation is atomic, so you can either undo it and do it again, or it just does nothing. Like he said, like, I already processed this event, I'm okay, you can continue. So this is in general. So to close like this one, EDA doesn't remove failures, it distribute them, and without observability, it's really hard to find them. Oh, I got to the next one. And this is kind of different. The eventual consistency challenge is kind of different because up until now we spoke about like a structure of the thing about the visibility. But this challenge, which is like is the definition of it's not a bug, it's a feature. It's a feature because. But this can cost us with trust. Essentially, we get to a point where people look at the data and say, like, is this data correct? Or the customer look on the state that doesn't know what happens. So if we imagine like scenarios that a payment is completed, I can see that I've been charged, my bank account, like you got the money, but in the UI, it's still pending. And I'm calling like customer support, so like, what happens here? And you look and said, oh, okay, we got the payment, but I'm still frustrated because I still see pending on the screen. And the funny or weird thing about eventual consistency that for us software engineers, it's okay, like we can deal with that. Like we are allowing the system to be wrong temporarily, and we're fine with that. But for humans, as customers, it's not fine. And we need to know how to deal with that. For concrete problem around the eventual consistency is that we have sometimes duplicates event, we have gaps in event, out of order delivery. Some services can, just died in the process, and then they need to consume the events again. So, to the tips that I've shared, but again, eventual consistency is not a bug. Okay, it's a price we need to pay because we distribute everything. So it's important also to make explicit decision about the consistency boundaries. Like what do we actually need to be consistent, and what we can we are okay with it to wait for a minute or two. By the way, once you decide which one is okay to be eventual consistent, you can also think about the user experience behind the scenes. So like if the payment that I just described takes a couple of minutes until I see the status, maybe it's better not to say pending, but we process your payment, the status will change in X. So be more transparent to your customers as well. Design, it's hard for me, this word always, idempottent consumers, sorry. Essentially, as we mentioned before, we want to make sure that the operation is atomic, so our services won't break when we get the same event twice. I had a nice bug when you click fast enough, you send a couple of events. I'm sure everybody tried it a couple of times, and then you either get a couple of orders or your system is blocking one of the events because it's identical. And the third one is the use outbox pattern. This is really help to make sure that you don't consume event a couple of times, and if prevent like missing event or theoretical one, and also help to replay if you need to. Prefer materialized view for read models. Essentially, that means that don't pretend data is real time. if it's actually don't, if it actually isn't. And you also should define SLAs for the data that is actually asynchronously. So essentially, if you have, I'm getting back to the example where I have the payment, and depending there, I should know as a producer how much time it takes to the UI to be refreshed. So if it's 1 minute, okay. If it's all of a sudden 5 minutes, somebody should be alerted and check what happens in the system. And this is maybe to your question, also handling ordering explicitly. Essentially, don't rely on the broker ordering. Make sure that you add maybe time step, maybe your own sequence, you to get out. Maybe your own sequence. Just make sure that you can look at the logs and know what the sequence of things that happens, because sometimes because it's asynchronously, if you just switch between consumers, it breaks the flow in non-obvious way, and you don't want it to happen. And again, I'm here to remind you that eventual consistency is not a bug, but it's really helpful, and we don't want to lose the trust of our customers. So we need to keep that in mind when we design it. So now we've seen most of the challenge, and it brings me to this one, because the question is not really is EDA is good or not, because we are going to use it. The problem that I've seen is that what happens when we use it for the wrong use cases. And essentially what I try to do is to collect a couple of questions that you can ask yourself in order to know whether to use EDA in general, or maybe just take the asynchronous way. And the first one is really the important one, is ask the multiple consumer question, because if you have one consumer that's going to consume this event, just do it synchronous. It doesn't make any sense to create this overload of events just for the sake of using EDA. Be honest about consistency lead. So most of the payment system that I know really use EDA because it is asynchronously, but some of the flows must be give instant response, and those cases are not suitable for EDA. Don't force workflow into event. We have nowadays beautiful tools to manage workflow, like when you have A, trigger B, then C. And if you're forcing EDA into this workflow, you just add some legs between each services, and everything becomes slow for not good reason. And this is the important one. And keep the option to say no, because EDA shouldn't be like an architecture that comes from above and said, from now on, you only use Kafka for all our development. You actually need to, when you think about new project, you actually need to understand the situation and see if the EDA, if the price we are paying to use event-driven architecture worth the benefit that we get. So keep the option to say no. So we talked about events, services, flow, but there is another system that EDA changes. Another system that EDA changes, and this is the organization. Because EDA didn't really change only the way the services communicate, it also changed how we communicate to each other, and this change also comes with the cost. I ask in general, and I also see that only yours is as a manager, so I'm not dive. Okay, so it's only you as your end, so you're, and only you close enough so I can see your name. And all these changes has a cost, essentially. And I'm not gonna talk a lot about it, but you also, as developers, should be aware of it, even just for the sake of raising a flag, so your manager would know. So what changed? First, I mentioned it like twice, and it wasn't by accident. Ownership become mandatory. Like events should be owned. The owner should be the one that understand it, document it, publish it, version it, support it, kill it in the future. So ownership doesn't, it's not an option. And the reality says that if the ownership is fuzzy, EDA won't fail. or won't fail loudly. It will fail slowly because we get to a point where we don't know what happens in the system anymore. Second is the coordination. One of the promises of EDA is that we have less meeting, less coordinations, but reality said that we still have a lot of coordination, but it's just asynchronously. So we are not talking about runtime failures, we're talking about design time discussions. And all of a sudden, it's not like who broke production, but like who consumed this event. So you still need to coordinate between the team, but it's just differently and more asynchronous way. So a lot of communication and probably a lot of Slack channels. Team boundaries matters a lot. EDA actually magnifies your boundaries. So if you have really strict and defined boundaries, it's reinforce it. But if you're fuzzy, if you have fuzzy browsers, you actually like expose them. Okay. What happens is that your architecture will reflect your organization, whether you want it or not. Essentially, you will have teams that interact with each other based on this architecture, even if you didn't meant them to work together. So you need to keep that in mind as well. Cognitive load is my favorite one because EDA is really, really easy to start, but really hard to keep in mind because all of a sudden you don't need just to know your service, you also need to know like flows, timing, retries, ordering, side effects that are not under my control but another side of the system. And we add events, so everything like accumulated and we need to know more. So really, really important, all the stuff that I've discussed about documentation and owner and writing things down because we cannot longer like hold everything in our head. And the first one, and I think this is like something new. We've seen like in the organization more platform teams nowadays because now you actually need more tooling, standards, guardrails. I don't want every one of my teams to, they invent the wheel and create everything. So platform maturity and becomes more requirements. And essentially all of this is a cost. It's not the infrastructure cost, which is easy to see because you have the dollar signs and you pay it every month, but it's the organizational cost that you need to take into consideration when we get there. And I must say, like, none of this that I mentioned is a reason to avoid EDA because it's like something to keep in mind for managers or for you to raise, like when you introduce something new, because it also shapes how the teams think, operate, communicate, and work together. So EDA works the best when you know what you are doing, but also when your organization is ready for that. So essentially, I try to collect some example, and to be honest, this is also generated by AI. Give me the best scenarios to use EDA, but I won't stall on this one. I want you to come back and remember the question you need to ask, because at the end of the day, every product or every system that we are building is different from one another, and you really need to think whether this is the right use case for EDA or not. And I collected some practical guidelines. So, like, if you need to take one photo, is this one. As a reminder, we want to treat events like a first-class citizenship, to create a contract, to make sure we design the event around the business, not the system. So essentially, if your product manager understands the event, you are doing a great job. If it's a reference to the database, like a row inserted or something, you need to reflect and see what you are doing. Make observability non-negotiable, so it will be very easy for you to wake up at 3 a.m. and find out what happens. Be intentional about when you use EDA, and also acknowledge the cost. So before I wrap up, I want to end the talk where we started with the dream, because again, the dream wasn't wrong. Okay, EDA promises us or enables us to actually build decoupled system at scale. It supports real-time system. It allows organization to grow beyond the boundaries of a synchronous system. But again, we shouldn't underestimate the cost, because if we do, we get, instead of the dream, we get the frustration. And if there is really one thing I want you to remember, is like to choose EDA not because it looks good on diagrams, not because it's popular, but because your domain, your system, and organization are ready for it. This is me, there, in LinkedIn, and I'm hiring, like a lot. So, yeah.